Welcome back, everyone. So today's explainer actually touches the literal foundation of our daily lives. We're diving into a critical industry standard from the SASB, which is now under the IFRS Foundation, focusing specifically on engineering and construction services. And the urgent theme we're unpacking today? It's how a changing climate is directly threatening the physical structures that you and I rely on every single day.
I want you to really think about this for a second. The next time you drive over a local bridge, walk into a hospital, or even just turn on a light switch powered by your local grid, ask yourself, is this infrastructure actually built to survive the climate of tomorrow? Or is it silently vulnerable to environmental extremes it was literally never designed to handle?
The document we're analyzing today offers a pretty stark reality check. Listen to this direct quote from the source standard. Entities in the industry increasingly must contemplate potential climate change impacts which may affect the project's structural integrity and public safety. You know, this isn't just some push for green PR. It's a very serious warning about the physical safety of our built environment.
To wrap our heads around this shift, we're hitting 6 quick checkpoints today. 1. The climate infrastructure collision. 2. Tracking hidden risks. 3. Structural integrity under threat. 4. The financial cost of failure. 5. Hydrocarbons versus renewables. And lastly, 6. Building a sustainable future.
All right, let's jump into Section 1, the climate infrastructure collision, a changing reality. Moving right into Section 2, tracking hidden risks, quantifying the threats.
So for decades, the engineering and construction industry has pretty much built the modern world based on historical weather data. But today, that industry is colliding head-on with new, totally volatile environmental realities. And, well, you can't manage a crisis if you can't measure it, right? That is exactly where the SASB standards come in. Now, I know accounting standards sounds a bit dry, but you should really view this as the industry's early warning system. It literally forces companies to disclose exactly how climate risks threaten their cash flows and their access to capital.
The sheer level of detail being tracked here is staggering. This framework holds the key to measuring everything from environmental noncompliance, we're talking illegal water discharges or hazardous spills, straight through to the actual structural safety of our buildings. By demanding hard, quantitative data on incident rates, monetary losses, and rework costs, it takes these invisible risks and turns them into undeniable numbers.
Which brings us to Section 3, Structural Integrity Under Threat.
Here is the urgent reality check. Minimum building codes might not be enough anymore. The source text explicitly warns that simply complying with applicable minimum codes might fail to maintain reputational value or even mitigate legal liabilities. Why? Well, because the frequency and severity of climate change-related events are expected to increase. Think about it. A bridge built to withstand a 1 in 100-year flood is in serious trouble if that flood is suddenly happening every 10 years.
To prevent these kinds of disasters, engineering entities just have to be proactive right from day one. They must contemplate climate impacts before drawing the very first blueprint, set up rigorous internal controls, and identify and fix potential design issues early. Meeting these heightened industry quality standards before a shovel even hits the dirt, that's really the only way to mitigate massive legal liabilities and absolutely ensured public safety.
Let's follow the money in Section 4, the financial cost of failure.
Because physical failures driven by climate negligence translate into massive corporate losses, specifically through something called rework costs. The definition is exactly what it sounds like: activities in the field that must be done more than once, or tearing out work you've already installed. If an entity fails to account for environmental impacts in their initial design, and that design fails, they have to pay for the labor, materials, and equipment to tear it all down and basically build it twice. Yikes.
But here's the thing. On-site rework is really just the immediate expense of a physical mistake. Contrast that against legal monetary losses. If a defect or a safety incident occurs, this standard tracks the devastating long-term costs of civil judgments, regulatory proceedings, fines, and even criminal actions. Failing to protect structural integrity isn't just an oops engineering mistake anymore, it is a massive financial and legal liability.
All right, on to Section 5, Hydrocarbons versus Renewables, Tracking the Backlog Mix.
The industry tracks its future pipeline of work through a metric called backlog. This is essentially revenue expected in the future from incomplete projects, and this brilliantly illustrates how the whole industry is shifting. The standard requires companies to break down their backlog, separating hydrocarbon-related projects like oil, gas, and fossil fuel electricity from renewable energy projects like wind and solar, as well as non-energy climate mitigation projects like mass transit. It's a direct window into whether a company is betting its future on carbon-intensive infrastructure or a green transition.
Embedding heavily on carbon-intensive backlogs carries a huge new risk: backlog cancellations. Evolving climate regulations, or even just failures to get permits, can suddenly turn a massive, lucrative hydrocarbon pipeline project into a canceled contract literally overnight. That long-term expected revenue? Entirely wiped out. It creates a massive downside risk for companies tied to extractive industries.
Let's look at the solutions in Section 6, Building a Sustainable Future. Life cycle efficiency.
So how does the industry actually adapt and thrive here? Well, a massive part of the solution is operational phase efficiency. The standard requires companies to rethink resource use entirely, incorporating water collection and reuse systems, improved insulation, strategic shading devices, and hyper-efficient lighting directly into the initial design. The goal is to dramatically shrink the building's daily footprint once it is actually operational.
And doing this isn't just some ethical choice, right? It is a serious business strategy. The standard points out that achieving third-party sustainability certifications like LEED, BREEAM, or Envision creates tangible competitive advantages. As client demand for economically advantageous, sustainable, and resilient infrastructure absolutely skyrockets, the companies that can deliver these certified projects are unlocking massive revenue growth. If they can't adapt, they will simply lose market share. It's that simple.
Which brings us to Section 7, the final takeaway. Built for tomorrow?
We've covered a whole lot of ground today, but it all comes back to the real world we live in. The physical environment around us is being tested in ways it quite literally never has been before. So I want to leave you with this. The next time you walk past a massive construction site, with the cranes in the sky and the concrete being poured, ask yourself, is that structure being built for the stable climate of the past, or is it truly designed to survive our volatile climate future? The answer to that question is going to define the safety and sustainability of our modern world. Thanks so much for joining me on this explainer, and I'll catch you in the next one.